Hi, this is Mr. Max. So, welcome to the third test on AS levels mathematics. So, this one here I'm doing questions on the modulus or the absolute value functions with a few polynomials in there as well. Right, so whenever you are solving the absolute value of 3x plus 3 is less than the absolute value of x plus 5, it's perhaps better if you use the fact that um, the absolute value of, let's say, a, when it's like less than the absolute value of something else like b, then perhaps it's best to use whatever that whole a square. So that means I'm going to say 3x plus 3 all squared should be, in this case, less than b squared, which means I'll say x plus 5 all squared. And then I'll solve the questions from there. Use that fact. So by now, I expect you to know how to do binomial expansion. So this one here is 9x squared. You have 9x plus 9x, that will give you 18x, plus 9 should be less than x squared. Double of 5x is 10x, and 5 times 5 is 25. Okay, so let's just rearrange this. This is 9x squared minus x squared plus 18x minus 10x plus 9 minus 25. That is obviously going to be less than 0. So again, if we have to clean this up, you have 8x squared plus 8x minus 16 is less than 0. Of course, what you can do here is to simplify. You can divide throughout by 8, since 8 is a common factor. And if you do that, you're going to end up with x squared plus x minus 2 is less than 0. So from here, if you were to sketch the graph, you would notice that the graph has a minimum point, and less than, we are looking for solutions below the x-axis. Okay, but the values will be excluded, the roots will be excluded. So in this particular case, solving this becomes quite straightforward. It becomes x plus 2 as well as x minus 1. So I'm going to say let that be equal to 0, because I want to find the critical values, which is the values that I'm going to have here and here. But remember, they will not be included in solution. So x plus 2 is equal to 0, or x minus 1 is equal to 0. So our values are therefore x equals to negative 2. That those are now our critical values. X equals to negative 2, or x equals to 1. So essentially, that is negative 2 is over here, and the 1 is over here. Right, so the critical values, remember we said the range of values, and this is a quadratic inequality after all. So the values will be a range of values that are between those two extremes. So x is going to be less than 1 and greater than or equal to negative 2. And that is our final answer. Okay, good. Well, there are many ways that you can solve this. So this is just me solving it one way. I think the other way would perhaps be if we were to make sort of a sketch. And let me bring in the software, maybe GeoGebra. So if I was to take the first one and I say y equals the absolute value of x, or is it 3x, 3x plus 3. So that is one. And the other one, which is going to use a different color, we have to say y equals the absolute value of x plus 5. And we're going to then also graph them together. So I'm just going to crop it so that you can see exactly what is it that we are looking at when we are solving it using the sketching method, or for you to see what that particular instance is referring to. So I'm just going to take these two functions. Okay, I'm just going to say it's question 1, and let me just bring it back in. So um, right, let's paste it over here on our clean document just to see how. Let's paste them here, or let's suppose we insert the image, and this is the image we're going to insert. Okay. All right. So what this now means, if we have our absolute value, so our absolute value, or it was initially um, the absolute value of 3x plus 3, which is the red, or let's just quickly make sure it's the green one, where it's less than the absolute value of x plus 5, which in this particular case is the red one. So the green one, where will the green one be less than the red one? It's where it's below. So it's when it's below. So it's basically from here. Can you see that it's below? It's below. So what is the range of values? Well, you can perhaps see by implication, it is from between 1 and obviously -2. So that's what we mean by that, okay? So when will one function be below? It will be when the values of x are as a range are less than 1, greater than -2. This is what we refer to. If you were to sketch it, that's exactly what it would mean, okay? If you were to solve it using that particular method. Okay, right, so that brings me to the second question. It says the points -4, a. So remember, this is a coordinate point, so that's the x coordinate. Is that the y coordinate? That's the x coordinate and the y coordinate respectively. They lie on the graph of y equals to the absolute value of x plus b. They say find the possible values, plural, of b and the corresponding values of a. Okay, so using the one that we have complete, so we have y is equal to the absolute value of x plus b. So we know that y here is 1.75 equals to the absolute value of b, that is 2, plus b. And of course, this therefore can be written as 2 plus b equals 1.75, or another one would be 2 plus b equals -1.75. So one value of b here would be, if you were to take it over, -0.25, or another value of b over here would be equal to -3.75. So now that we have our two values of b, now we're going to find the corresponding values of a. And the way we do that is we simply say, remember we have, if we were to write it down, we have y equals to x plus b. But now our y from this particular point, our y is a. So that will be a equals to, let's take our value of x. Our value of x is -4, as you can see from this particular point over here. So that would be -4. I'll just go ahead and I'll put it in brackets. And then we have a value of b. So if I take the value of b of -0.25, that is going to give me one possible answer for a, and the other one would be -4 plus -3.75. Whatever they will be, those will give me the two values of a. Right, so over here you're gonna have a equals 4.25, or you're going to have a equals 7.75. All right, so our solutions therefore is if a equals 4.25, then b equals negative 0.25. That's one solution. The other one would be if a equals 7.75, then the value of b likewise will be negative 3.75. So those are my two or my various solutions that you can actually record. Okay, there we go. All right, straightforward question. Let's get to question 3. Solve the equation. The absolute value of x cubed minus 14 is equal to 13. So, well, of course, you're going to drop the absolute value signs and you're going to say let it equal to 13 or let it equal to negative 13. So, in this case, you're going to have x cubed minus 14 equals to 13, or you're going to have x cubed minus 14 equals to negative 13. Of course, you're going to have here x cubed equals to 27, that is if you take the 14 over, or x cubed equals to 1. Now, if you were to remove to find the value of x, you will be taking the cube root of 27, or you will be finding the cube root of 1. So x is therefore equals to 3, or x is equal to 1, because the cube root of 1 is just 1. All right, so don't forget also to check your answers and to make sure that they both check out, put them back in the absolute value sign, and of course you'll realize that it's going to work. All right, for example, if you have 3 cubed minus 14, all right, if x is equal to that, this obviously gives you 27 minus 14, which is the absolute value of 13, which in any case is also then equal to 13, which is equal to 13. So it checks out. So if we then also do the same for 1 cubed minus 14, well, you have the absolute value of negative 13, which is also equal to that. So both these solutions therefore are going to work. So these solutions therefore, both of them will definitely work out. Okay, right, so let's go to the next question. So this question is not that complex, but it's something that you are supposed to actually pay a little bit of attention to. So you have got two functions. One is a parabola, and as you can see from that parabola, if you were to multiply out at negative a half x with everything inside, it's going to give you a negative a half x squared, which means if you were to sketch this, it will have something that has a maximum. But in this particular case, they say write down the coordinates of the x-intercept um, of the graph of f of x, and you are supposed to give your answer as a coordinate. So that's nothing but you take the negative a half of x um, and you let that equal to 0. So negative a half of x equals to 0, or x plus 6 equals to 0. In this case, x will equal to 0, or x will equals to negative 6. So the answer therefore as coordinates will be the x-intercepts will be 0, 0, and the other one will be negative 6, 0, because again they ask us to give the answer as coordinates. So very important that you do so. Okay, the second part, now they want you to sketch the graph of minus a half of x. Now we know where the graph cuts the x-axis. It will cut the x-axis at 0, and -6. We are also now supposed to find the turning point of the graph. So if you were to find a turning point, and I will do it here, we know the y-intercept is equal to 0. The graph of f of x equals to negative a half of x and x plus 6. So the y-intercept is taking place at 0, so it will be at the origin. The turning point would be where x equals minus b over 2a, which in this particular case, if you had to take the value of b, supposedly if you were to multiply out this one here, it will give you a negative a half of x squared, and then minus, and if you have a half, that's going to be minus 3x. So the value of b here will be negative, that will be negative 3 over 2 times negative a half. Of course, you have a positive up there, a negative here, the answer will be negative 3. So the turning point, if I have to write it down, the turning point will be negative 3, and to find the y value of the turning point, we take this value and we put it into the function. So if we say f of negative 3, and we are going to get as an output everywhere where we have a half, so we are going to have perhaps I can also use the one that I multiplied out, doesn't matter, minus 3 times that. So once I input negative 3, the f of negative 3, I'm going to get a value of 4.5. So therefore, my turning point will be at point negative 3, comma 4.5. So now that I have my turning point, now that I have my x-intercept, my y-intercept, I can actually go ahead and I can sketch this. Okay, now the sketch might not be perfect, but just bear with me. All right, so you know that it has to pass to the origin, so it's going to go all the way like so, and then obviously it's going to come down like so. So it's a little bit sloppy. Maybe I can just rectify it a bit more. Let's see if it goes slightly better. Okay. Okay, maybe you will do much better work than me. Remember, it must pass at the origin. So that is the point 0, and this one here is the point negative 6. Our turning point is the point negative 3, comma 4.5. Okay, so we have therefore sketched that particular graph, and this is the graph of f of x together. Okay, now they say use the graph from part B to determine the values of k for which you have this has two unequal roots. So first of all, let me just make sure that this is also the same by dividing throughout by 2. And if I do that, I'll have negative a half of x plus 6 equals to k. So this k now means a certain value because it's in the place of y. So y equals to k, which means it's a horizontal line that we need to draw because horizontal lines are in the form y equals to k, where k is some constant. Now, what it says is where can we draw in order for us to find that range, the values of k. So which values would they be such that the roots, they're unequal negative roots? So if I were to draw a horizontal line, um, let's suppose I was to draw the horizontal line over here, then you will see that one of these roots will be positive and one of these roots will be negative. So therefore, in a nutshell, if I was to take that line and I move all the way up here, can you see that? Of course, let's suppose that part. You'll see that one root here will be negative, so one root be negative. So basically, from 0 all the way up to the turning point, you're going to have one root will be negative and the other one will be negative. So what we are then saying is for that line to satisfy our condition, that line y equals to k, for it to have two negative roots, it must take place between 0 all the way here up to 4.5, né? That 4.5 being over there. So our k value, would be between big value 4.5 and 0, but not included, because if it's there it will just have one solution. If it's here, then other solution will be 0. So our k value should be whatever the line is. It's either y equals to anything between 0 and 4.5. So y equals to 2, for example, is going to generate the same thing if I was to draw that. So that is how the B part of that question is therefore answered. So it would be k is less than 4.5, the range, and greater than 0. So surely I hope you have understand that, because you are supposed to use the graph, and the graph will give you a guidance as to how to approach that question. Okay, now they want us to draw this on the same sketch that we have the graph of y equals to the absolute value of x. Now it's quite straightforward basically to draw that graph. So the graph of y equals to the absolute value of x would just be, I will draw the graph of y equals to x and y equals to negative x. So if I was to go back to my graph, okay, maybe I'll remove this line over here so that it's not in the way. Also, maybe I'll remove this over here, and perhaps also remove all of these. Just remove them so we can just create some space. Okay, and even maybe my 0, I'm going to move my 0. So if I move my 0, of course, my 0 will now be over here. Right, so if I have to draw the graph of y equals to the absolute value of x, so this g of x, so it's going to go in this direction, and then obviously its reflection then in this other direction. Okay, and this is going to be the graph of g of x. Okay, so that's what they said we should do on the same axis. Right, now it's very important, if we were to draw or to solve part E. Now part E is asking us to determine the values for which the function, the f function, is greater than or above g. So it's obviously going to be from this part, because you can see that function f is greater than function g there. So of course we can see the knot, but now we need to determine what is this point here. What is this point here? So that is what our emphasis should be. How do we find that point where the two graphs are intersecting? And I think in saying that intersecting, I actually gave you already an idea as to how to find that. So let's suppose I brought in a clean page here, so I'm going to do it over here. So, but remember, um, the graph is only going to be greater than the other one, obviously, once it's this particular part of the function, that is y equals to minus x. Can you see that? So basically, this is the line y equals to minus x, and that is line y equals to x. So I'm just going to then say equate it to minus x and not just equate it to positive x, because I don't need that. Okay, so when I take my g of x function, remember now my g of x is equal to the absolute value of x. So I can have g of x is equal to minus x, or I can have g of x is equal to x, but I don't need this because that will be on the positive sign, so I'm going to take this. Then I'm going to take the two functions which the other one was negative a half of x. Remember that one? Let's just clean this up, write it neatly. Negative half of x, then it was x plus 6, and I'm going to say let that equal to minus x. And I'm going to obviously solve this and see where it brings me. So when I have a negative and a negative here, they cancel basically, a negative times that. So I'm going to have x here, x plus 6, and that's going to equal to 2x, because a negative a half times that is going to be 2x. All right, so let's continue then. So if I have to bring it over, I'll have x squared plus 6x minus 2x is equal to naught. So that's x squared plus 4x is equal to naught. In fact, it's actually going to be very easy now for me to find the answer. The answer would just be x is equal to 0 or x equals to negative 4. Right, I don't need the 0. So what that means is if I have to go to my graph, I can see they intersect x equal to 0, but the other one here, that point there where they intersect, that is negative 4. So this particular point here is the point negative 4. What would be its corresponding y value? So I'll just take that and substitute it into the formula. I will not necessarily substitute into the f formula. Okay, so I'll just say, okay, if you have g of x, which is equals to the absolute value of x, so when g is of negative 4, and then if I do that, that gives me 4 as an answer. So basically, I can now find my output value, and my output value here is 4. So that would be the y value there. Right, so now I know where the range is, the ones in yellow. So it's between from negative 4. Now it's these ones here. That's what I'm looking for, the values where the graph, the blue one or the F graph would be greater than or would be on top of the absolute value graph. So the way we are going to write it, we're going to write it as an inequality, and it's very simple the way we're going to write it, and we're just going to say that is going to occur where x is less than 0 or greater than negative 4. Okay. Right, question 5. Well, this question here is about a polynomial, and a very similar question came into the exams of last year, 2023. Okay, so they want you to, they say, find a quotient when p of x is divided by x plus 2 and show that the remainder is equal to 5. So I'm going to use synthetic division, but you can go ahead and you can do long division if you want to. So when I use synthetic division, the first step is I'm going to let that divisor equal to 0. So I'm going to work with negative 2, and then I know that, okay, so I'm just going to now write down the coefficients down, and this little block over here would be for my remainder. Okay, so this is going to be 8, the coefficient. That is going to be 30 and 13 and negative 25. Okay, um, so first step is to bring this 8 down. When you do so, multiply 8 times 2, well, that's negative 16. And when you are now adding, you're going to get 14. Again, if you were to multiply, you get negative 28. If you were to add, you get negative 15. And a negative gives you positive 30. And if you add, you get a remainder of 5. So the quotient, therefore, the quotient would be 8x squared, should be now 1 degree less than that, plus 14x minus 15. And then obviously the remainder, we can see the remainder is nothing but 5. Okay. Of course, you're welcome to do long division if you so wish to. You would realize that you would also arrive at the same quotient and at the same remainder. Some people use the remainder theorem just to prove what the remainder would be, but we already know that the remainder is going to be 5. All right, so that's what we're looking for there. Now, I'm going to jump to the other page. Now they say we must factorize. So what we are factorizing is we're going to factorize this p of x, which was p of x. Remember, p of x was nothing but 8x cubed plus 30. What is it? 30x squared plus 13x minus 25. Now, if you were to minus 5 here, you would now end up with 8x cubed plus 30x squared plus 13x minus 30. Okay, that is what that now gives you, which means that our previous answer of our quotient now, that 8x squared plus the 14x minus 15 is going to be the quotient, and there won't be a remainder if x plus 2 is a factor. Now, if that is the case, um, we can actually find the other two factors, because I have already one where I have x plus 2. Just remember that. Very important that you also take note of that, because you actually uh, you just have to make sure that you understand that concept. Here in the first part, um, we were when we were dividing this or using synthetic division, x plus 2, there was a remainder, and the remainder is 5. But if we say now the whole function minus 5, then it means there's no remainder. Therefore, this 8x squared plus 14x minus 15 would be the other, that will go into that. So we'll only have to factorize 8x squared plus 14x minus 15 now. And we don't have to do the whole thing over again with long division. So it's just a matter of us now finding the two other factors. So I'll give you the benefit of doubt to see that you're going to arrive at the other two factors as that, and that should be the final answer. Remember how to factorize. You have the quadratic already, so it's just you have the you have the linear one, so you can do short division again to find that, or synthetic division, or long division rather, to find the other two. Right now here they are saying write down the roots. So here it just means you take each one of those and you let them equal to 0 in order for you to find the roots. So x plus 2 equals to naught. So x would be negative 2, one answer, or 2x plus 5 is equal to naught. If you were to go around with that, you're going to get negative 5 halves. That will be another answer. Or if you take 4x minus 3 equals to 0, that will give you 3 over 4. So all of these three that I have there are the roots of the equation. And it's just 1 mark for doing that. Okay, you can go ahead and write them x equals to x equals to. I'm just rather taking the shortcut. Good. Right, so this was the test that I had on polynomials and absolute value. So I hope that it has been a bit worthwhile. You'll also see, as again, as I said, I'm going to do this one tomorrow, which is the one on sequences and series. And what I do after that, there are two tests that I'm going to do. The other one will be sigma notation and sum to infinity. And then the third test will be the binomial theorem. Okay, and then I'm going to move on from that chapter, and I'm going to go to logs and logarithmic functions and exponential functions, and that is how we are going to do. So that is in theme 2, but just bear with me. That is the way that we prefer to do the scheme of work, or to work through that stuff.